Let's talk about nicotine. When you hear that word, I bet your brain jumps straight to cigarettes. Addiction, danger, right? But what if I told you that same chemical is getting tested right now as a potential treatment for things like Parkinson's and even long COVID? Yeah, it's a lot more complicated than we've been led to believe. So let's get into it. So this is really the heart of the mystery we're unpacking. Is nicotine the bad guy, the chemical that's got over 1 billion people hooked on tobacco? Or could it actually be a good guy, a potential medicine that's just been misunderstood because of where we usually find it? I mean, just look at this contrast. On one side, you've got the psychoactive compound that drives a global addiction crisis. And on the other, you have that exact same compound being used in skin patches, showing real promise for helping people with some really serious conditions. How on earth can both of these things be true at the same time? To figure this out, we have to go inside the brain. We need to look at what nicotine actually does when it gets in there. Because what it does is it basically hacks the most fundamental parts of our brain, the systems that control reward and motivation. Okay, it all kicks off with these things called nicotinic acetylcholine receptors. You can just think of them as the little docking stations all over your brain. Nicotine has the perfect shape to slide right into these docks, like a key into a lock. And when it clicks in, it sets off a chain reaction. And that chain reaction is powerful. The nicotine binds to the receptor and boom, that signals your brain to release a flood of dopamine. That's the famous feel-good chemical. Your brain gets this huge hit of pleasure and reward, and it immediately learns, hey, that was great. Let's do that again. And it's not just us saying that. Here's how neuroscientist Dr. Andrew Huberman explains it. Super simple. Nicotine increases dopamine, and that's why it feels so good. It makes you want more of it. It's a biological command. It hijacks the very system that's meant to keep us alive and points it toward the drug. And here's the really clever, or kind of devious part. Nicotine doesn't just stomp on the dopamine gas pedal, it also cuts the brakes. It reduces the effect of another chemical called GABA, which is supposed to slow things down. So you get more dopamine release and less of the stuff that's meant to stop it. It's an incredibly effective 1-2 punch.
Okay, so that's what's happening in your brain. But what about your body? If you were, say, part of one of these studies using a nicotine patch, what would you physically feel? Because this isn't just happening in your head. Nicotine is a stimulant, and it gives your whole system a jolt.
Your body pretty much immediately kicks into a higher gear. Nicotine triggers a release of adrenaline and noradrenaline, your classic stress chemicals. That means your heart starts beating faster, your blood pressure goes up, your blood vessels tighten, and you start breathing more rapidly. It's basically flipping the fight or flight switch on. And this isn't just some textbook list. We have reports from actual people. In a study using nicotine patches for long COVID, a patient described feeling an unpleasant feeling of tightness in their chest and even episodes of palpitations. So yeah, even from a patch without any smoke, users can definitely feel that physical kick. So we've got this chemical that rewires your brain for addiction and acts as a powerful physical stimulant. Sounds pretty bad, right? Well, hang on, because this is where the whole story flips on its head. This is where we look at nicotine as a potential medicine. Scientists are seriously looking into nicotine's ability to do things like sharpen focus, cut through brain fog, fight fatigue, and even reduce inflammation. And if you think about it, those are the exact problems that people with conditions like ADHD, Parkinson's, and long COVID are dealing with every single day. But here's the question that's probably on your mind. If we give people nicotine, aren't we just setting them up for a new addiction? Well, this is probably the most shocking part of the whole story. In clinical trials, when it's delivered slowly through a skin patch, addiction is almost a non-issue. It's incredibly rare. And the data is just stark. This quote from a research paper sums it up perfectly. After reviewing a bunch of these trials, they found that none, literally none of the trials could show any sign of dependency after people stopped using the patches. Zero. So this brings us right back to this central puzzle. It is the exact same molecule going into the body. How can it be one of the most addictive substances known to man in one form and almost completely non-addictive in another? What in the world is going on? And the answer, it turns out, is surprisingly simple. It's not about the what, it's all about the how. The whole secret to nicotine's two faces is the delivery method. Think about speed. When you smoke or vape, nicotine slams into your brain in a matter of seconds. It's a huge, rapid spike. Gum is slower, maybe 5 minutes, but a patch? A patch delivers a low, steady, consistent dose over hours and hours. There's no spike, there's no rush. This chart does a fantastic job of explaining everything. It plots different nicotine products on 3 scales. How harmful are they? How appealing or satisfying are they to a user? And, the big one for us, how likely are they to cause addiction?
Now, look way up here in the top corner. That's where you find burned tobacco, like cigarettes. They are maxed out on everything. They're the most harmful, they create the biggest rush, so they're the most appealing, and they are, by a huge margin, the most addictive. And now look all the way down here at the complete opposite end of the chart. That's where you'll find nicotine patches. They're at the bottom on every single scale. Least harmful, least appealing in terms of a rush, and they have a very, very low chance of causing addiction. It's the same chemical, just in a totally different vehicle. So here's the takeaway. That super fast, massive spike you get from smoking is what hijacks your brain's reward system and forges the chains of addiction. The slow, steady delivery from a patch, on the other hand, gives the brain the chemical and its potential benefits without that addictive, overwhelming rush. It's really the difference between a fire hose and a garden sprinkler.
And finally, we have to make this crystal clear: nicotine is not tobacco smoke. They are not the same thing. When you burn tobacco, yeah, you get nicotine, but you also get a disgusting chemical soup of over 599 other additives, plus all the toxic junk created by setting it on fire. The overwhelming harm comes from the smoke, not the nicotine by itself. So let's just quickly recap the big points here. 1. Nicotine is a powerful stimulant for your brain's reward system. 2. It has real physical effects, like raising your heart rate, that you can actually feel. 3. Its addictive power has almost everything to do with how fast it hits you. And 4. The real killer in smoking is the smoke itself, the thousands of other chemicals, not just the nicotine. So that leaves us with a really big question to chew on. We've just seen how a substance's profile can completely change from a dangerous addictor to a potential medicine, all based on how it's delivered. So it makes you wonder, if the danger is so often in the delivery method, what other substances out there might we be completely misunderstanding?